Look up into the night sky. Every star you see, silent, distant, ancient, belongs to a vast spiral of motion. Our own Milky Way is one of them, a flat disk of hundreds of billions of stars, all circling a common center, completing one great turn every 230 million years. And within that grand celestial dance, we seem completely still. No tremor, no sway, as if the universe itself were asleep inside its own motion. But what if that stillness is only an illusion? What if everything, from the smallest particle to the greatest galaxy, is spinning, and within that motion, life finds its rhythm to breathe? Hello, and welcome to Moon Whisper Sleep, where science meets serenity, and every motion becomes a lullaby of light. Perhaps tonight, you just want to close your eyes and let your mind drift among the stars. A place where everything moves, yet feels so peacefully still. Wherever you are, no matter how heavy your day has been, this journey is for you. Let your breath slow down. Let your thoughts dissolve like stardust in the air, and feel your body grow lighter, as if gravity itself has loosened its hold, and you begin to float softly through the quiet ocean of space. Tonight, we'll follow the rhythm that keeps everything turning, from the spin of atoms to the dance of distant galaxies, and discover what it means to be part of that eternal motion. There's no rush, nothing to solve. Just drift and listen to the whispers of the cosmos, where every breath, every thought, is a tiny rotation in the endless symphony of time. If you find peace in this stillness, if this calm makes you smile, please like, subscribe, and ring the little bell, so that each night, the universe can find its way back to you through the gentle whispers of Moon Whisper Sleep. And who knows, maybe your quiet touch will become a small signal, a light guiding someone else who's awake in the middle of the night, to this place of rest, of learning, and of gentle sleep, one soul at a time. Close your eyes for a moment. You're sitting quietly in a familiar room, surrounded by stillness. And yet, right now, everything around you, even your own body, is moving faster than you can imagine. The earth beneath you spins at over 1,000 miles per hour, while it races around the sun at nearly 67,000 miles per hour. And our entire solar system itself drifts around the Milky Way at almost 500,000 miles an hour, gliding through a sea of stars. But we feel nothing. No trembling, no rush of air, no sense of motion. Our heartbeat stays steady, our breath unshaken. The world feels frozen, even as it turns through space. Why? How can everything move so fast, and yet we feel completely still? The answer lies in a quiet, ancient truth, the law of inertia. In the 17th century, Isaac Newton wrote, "An object in motion will remain in motion unless acted upon by an external force." That simple idea explains why we don't feel the Earth's constant spinning. You, the air you breathe, the oceans, the mountains, all are moving together, locked in the same rhythm. There's no sudden push or pull, no resistance. It's like being on a perfectly smooth ship gliding over a calm ocean. You only feel movement when the ship changes speed or direction. But if it sails smoothly, you might as well be standing still. Space itself is almost a perfect vacuum. There's no friction, no air resistance to remind us that we're moving. The motion is so even, so seamless, that it disappears from our senses. What we call stillness is really the harmony of constant motion. Astronauts describe this perfectly. Orbiting Earth at more than 17,000 miles per hour, they don't feel the speed. Inside the spacecraft, everything seems calm. Objects float gently in the air. This state is called uniform motion, movement at a constant speed and direction. As long as velocity doesn't change, the human body can't detect it. Think of sipping tea on an airplane cruising at 900 kilometers per hour. The tea stays still until turbulence disturbs the uniform motion. The same happens with Earth. Its rotation and orbit are remarkably smooth, nearly unchanged for billions of years. Because there are no jolts or abrupt changes, we move together with the planet in perfect synchrony. If you ever visit a science museum, you might see a Foucault pendulum, a long cable with a heavy ball swinging gently from side to side. At first glance, it just moves back and forth. But if you watch for hours, you'll see its swing slowly change direction. It isn't the pendulum that turns. It's the Earth beneath it. In 1851, French physicist Léon Foucault used this simple experiment to show that our planet truly spins. Each slow drift of that pendulum is like a visible breath of time, a quiet reminder that motion never stops, even when it feels silent. The balance system inside our ears, the vestibular system, evolved to detect acceleration, not steady speed. It helps us walk, run, and climb, not to sense the rotation of a planet thousands of miles wide. It responds only to changes in motion, not to motion itself. That's why you feel the start of a car, but not its steady cruise. So, while the Earth spins, the Sun pulls, and the galaxy drifts, your brain interprets the absence of change as calm. In truth, you are falling endlessly around the Sun, following a curved path through space, yet you feel nothing at all. Earth's rotation isn't just a mechanical detail. It's the heartbeat of life itself. That constant turning gives us day and night, stabilizes the magnetic field, and protects our world from harmful solar radiation. If the Earth ever stopped spinning, one half of the planet would bake under eternal sunlight, while the other froze in darkness. The atmosphere would collapse into chaos. No wind, no weather, no rhythm. NASA simulations show that even a 1% change in rotation speed would alter global winds, storm patterns, and temperature cycles. The Earth's steady spin, therefore, isn't just physics, it's balance, it's life. Every sunrise, every wave on the ocean, every breeze is a quiet echo of that ancient motion. When we look up at night, the stars appear frozen. But in reality, every one of them is moving, some racing through space at hundreds of thousands of kilometers per hour. The Milky Way itself is drifting, and even the universe continues to expand. We can't sense this cosmic movement because everything, from atoms to galaxies, moves together. There's no difference to compare against, no friction to remind us. That's why stillness is not the absence of motion. It's the perfect coordination of motion. A physicist once said, "If you could truly feel every motion happening around you, you wouldn't be able to stand." The calm we feel is not the world standing still. It's the result of countless motions woven together so smoothly that they cancel out in our senses. We call that illusion peace. Take a breath. Feel your heartbeat. It too is a cycle, a rotation of blood through heart and lungs. Each inhale and exhale is a small oscillation, a rhythm. Even your thoughts come and go in waves. Now imagine zooming out to the turning Earth, to its orbit around the Sun, to the galaxy's long spiral dance. You are part of that movement, not separate, not stationary, just synchronized. Stillness is an illusion. You are moving, but your motion is too complete, too harmonious to be felt. Tonight, when you look up at the stars, remember, the light you see is not frozen in the sky. It is still moving, still spinning through time and space. And you, right now, are moving with it. You are part of the great turning, a quiet rhythm that began long before you were born and will continue long after. The stillness you feel is the sound of everything moving together. perfect balance. Cosmic breath. The quiet you feel is not stillness. It is harmony, everything moving together. If you could turn back time, not just centuries or millennia, but all the way to the first heartbeat of existence, the very beginning, what would you see? Would there be light? Would there be sound? Or would there only be motion? A gentle swirl, the first rotation of everything that would ever exist? The question of who or what set the universe spinning isn't about mythology or belief. It's a question of physics, of how motion, order, and time themselves were born. Physicists call that instant the Planck era, the first 10 superscript 3 seconds after the Big Bang, a time so early that our current laws of physics can barely describe it. Matter, energy, and even space-time were fused into one chaotic field of possibilities. Gravity, electromagnetism, and the nuclear forces were not yet separate. They were a single force, the raw potential of motion waiting to unfold. We don't know exactly what happened then. No telescope can see that far back. Light itself didn't yet exist. But traces remain, the cosmic microwave background, a faint afterglow detected by satellites like WMAP and Planck. Within that glow are tiny ripples, differences in temperature of only a few millionths of a degree. Those irregularities were the seeds of everything: galaxies, stars, and eventually, us. Some early analyses found a subtle alignment in those ripples, a pattern across the sky that seemed to prefer one direction. It was nicknamed the axis of evil, but most cosmologists today see it as an intriguing curiosity. Perhaps an artifact of measurement, perhaps a coincidence. Not proof that the universe spins like a cosmic wheel. Still, it raises an irresistible question. If motion is everywhere, could the universe itself have begun with motion, not from rest? At scales smaller than atoms, nature is never still. Even in a perfect vacuum, quantum fields fluctuate, tiny jitters of energy appearing and vanishing in an endless rhythm. When the universe was smaller than an atom, these fluctuations were magnified by an event known as cosmic inflation, a rapid exponential expansion proposed by physicist Alan Guth in 1981. During inflation, the universe grew from subatomic size to astronomical dimensions in a fraction of a second, faster than the speed of light. Those tiny quantum jitters were stretched into vast waves of density. Some physicists suggest that, in this process, even small twists or rotations within those fields could have been amplified, giving rise to the first hints of cosmic spin. While direct evidence of this primordial rotation remains uncertain, scientists search for its fingerprints in the sky. They look at polarization patterns in the cosmic microwave background, subtle swirls called B-modes, which might reveal how space itself moved during inflation. So far, no definitive signal has been confirmed. What we have are possibilities, not proof. But these patterns remind us of one profound truth. Motion did not have to be added later. It may have been inherent from the start. Every spinning thing, from a child's toy top to a galaxy, obeys the same simple rule: conservation of angular momentum. When a figure skater pulls in her arms, she spins faster. When gas clouds collapse under gravity to form stars and planets, they too spin faster. Nothing can start spinning without a cause. Motion must come from motion. This law suggests that every planet, every atom, every turn of the Milky Way inherits its spin from something older. Earth's 24-hour rotation is a fossil memory of the solar system's birth, when dust and gas swirled around a young Sunday. Even the sun itself spins once every 27 days, dragging magnetic fields through space. And the Milky Way completes one grand rotation every 230 million years, carrying hundreds of billions of stars along in its spiral arms. Rotation, then, isn't an accident. It's a memory, the echo of an ancient motion that the universe has never forgotten. In the beginning, the universe may have been perfectly symmetrical, no difference between one direction or another. But perfect symmetry is sterile. Nothing changes in a perfectly balanced state. Physicists call the loss of that balanced symmetry breaking, the moment when a flawless pattern tips slightly and gives birth to structure. As the universe expanded and cooled, the unified forces began to split apart. Gravity separated first, then the strong and weak nuclear forces, and finally electromagnetism. Each separation introduced a tiny asymmetry, a slight preference, a tilt. Those imperfections allowed matter to clump together, stars to ignite, and galaxies to form. Without them, everything would have remained an endless, uniform mist. So perhaps the first spin was not a deliberate act, but a natural consequence of imperfection. A tiny imbalance in the earliest energy fields might have caused space itself to twist, gently, then grandly, until rotation became the rule, not the exception. When astronomers study thousands of spiral galaxies, they find that roughly half spin clockwise and half counterclockwise, as if the cosmos favors neither hand. But statistical noise and local clustering make the balance imperfect. Some surveys hint at small imbalances, though these results are debated. Whether or not a cosmic handedness truly exists, it reveals something deeper. Nature seems to tolerate, even depend on, tiny departures from symmetry. At the subatomic scale, this preference becomes striking. Particles called neutrinos always spin in one direction, left-handed, a fundamental violation of mirror symmetry. It's a quiet reminder that even at its smallest scales, the universe isn't perfectly balanced. And those small imbalances, magnified over time, may be what allowed everything else, including you, to exist. Modern cosmology suggests that motion is not a temporary state, but a defining property of existence. Even the empty regions of space hum with fluctuations, the faint whisper of fields that never truly rest. As the universe aged, these early vibrations shaped the geometry of everything, from atoms to clusters of galaxies. Astronomers today can observe light that has been traveling for more than 13 billion years. Even those first galaxies show rotation, organized, patterned, graceful. This means the seeds of spin were already present almost immediately after the Big Bang. The universe didn't learn to move, it was born moving. So who, then, set it spinning? Perhaps no one. Perhaps motion is the universe's natural language, its way of existing. In physics, angular momentum can neither be created nor destroyed, only transferred or shared. Once motion exists, it sustains itself, cascading across scales like a melody repeating through time. When you look up at the night sky, remember, every star, every planet, every atom is part of that original motion. Your own heartbeat, the spin of the Earth, the orbit of the Moon, all trace back to that first moment when symmetry broke and motion began. The question, who set the universe spinning, may never have a single answer, but perhaps the most honest one is also the simplest. No one needed to. The universe has always known how to move. Take a slow breath. You are still turning with that first impulse, a silent rotation that began nearly 8 billion years ago. And as long as time exists, that motion will continue. Calm, unbroken, eternal. Motion is not something the universe learned. It is what the universe is. Imagine standing at the edge of dawn. The sky is painted in soft hues of blue and rose. You feel the air shift, the light stretch across the horizon. And in that moment, you are witnessing the quiet consequence of one cosmic motion, the spin of Earth. Every sunrise, Every wave, every breath of wind is a ripple from that ancient rotation. And yet, how often do we stop to realize that without this endless turning, life itself might never have emerged at all? The Earth has never truly stopped moving. Since its birth 5 billion years ago, it has spun like a slow, breathing heart, completing one rotation every 23 hours, 56 minutes, and 4 seconds. That rhythm defines the cycle of day and night, the heartbeat of all living systems. Early in the planet's history, it spun much faster, one full rotation in just 5 or 6 hours. Over billions of years, the gravitational pull of the moon gradually slowed it down, stretching days longer, softening tides, and stabilizing the planet's tilt. That gentle braking by lunar gravity became one of the most important cosmic balances ever achieved. If the Earth had kept spinning at its original speed, winds would have raged at thousands of kilometers per hour. The surface would have been torn by constant storms, and the oceans churned into chaos. But if it spun too slowly, half the world would bake in eternal sunlight while the other froze in endless night. Only at this delicate rhythm, neither too fast nor too slow, could temperature, atmosphere, and chemistry find harmony. Life was born in that balance. Because of Earth's spin, no place is condemned to darkness forever. Every point on the surface takes turns facing the sun, receiving light, warmth, and energy in cycles that foster adaptation. Plants evolve to follow this rhythm, opening their leaves in the day and folding them at night. Animals learn to rest, hunt, and reproduce in sync with the rotation. Even the human body carries an inner echo of this motion, the circadian rhythm, a biological clock that follows the day's rotation like a whisper of the planet's spin inside our cells. Inside your brain, a cluster of neurons called the suprachiasmatic nucleus keeps track of this 24-hour cycle, telling your body when to sleep, eat, or release hormones. If the Earth stopped spinning, this internal clock would lose its anchor. We would live in a world where day and night had no meaning, a world without rhythm. And rhythm, more than anything, is what life depends on. But rotation does more than create day and night. It also protects life. Deep inside the planet, molten iron and nickel swirl in the outer core. As the Earth spins, those liquid metals move like a vast dynamo, generating the magnetic field that surrounds our planet. This invisible field deflects charged particles from the sun, the solar wind, which would otherwise strip away our atmosphere and fry the surface with radiation. Without this magnetosphere, Earth might have ended up like Mars, dry, frozen, and exposed. It's this constant churning, powered by planetary rotation, that keeps the shield alive. When you see the aurora, curtains of green and violet dancing near the poles, you're watching the Earth's magnetic heartbeat made visible. Spin, quite literally, is what keeps the breath of life from being blown away. The rotation of the Earth also gives rise to one of the planet's most beautiful and complex systems, the atmosphere in motion. Because the planet spins, air doesn't flow straight from the equator to the poles. It bends, twists, and spirals, creating the Great Coriolis effect. This twist shapes global wind patterns, steering storms, trade winds, and jet streams. The same is true for the oceans. Currents curve and circulate, carrying warmth across the globe. The Gulf Stream brings tropical heat to northern Europe. The Pacific currents regulate monsoons across Asia. These immense flows are not random. They are the echoes of rotation, translated into weather and climate. If the Earth stopped spinning, these flows would collapse. The equator would roast, the poles would freeze, and much of the planet's water would migrate toward the extremes. The thin line of habitability we now enjoy would vanish. In short, the world breathes because it spins. Spin doesn't just shape the planet. It defines our sense of time. Before there were clocks, before there were calendars, there was rotation, the earliest measure of duration. One turn of the Earth gave us the day. One orbit of the Earth around the Sun gives us the year. Even the ancient Sumerians, Egyptians, and Mayans watched the sky not for stillness, but for cycles, rising and setting, waxing and waning. The very idea of time came from motion. Without rotation, there would be no sunrise to mark beginnings, no sunset to mark endings. There would only be eternity, unchanging and lifeless. Perhaps that's the deepest reason we find peace in watching the sky turn. It reminds us that time is not something we measure. It's something we participate in. As the Earth spun through deep time, its steady rhythm shaped evolution itself. Life adapted not to stillness, but to cycles, of light, of gravity, of motion. Marine organisms rise and fall with tides governed by the Earth, moon dance. Plants use rotational cues to orient their leaves. Even DNA repair and cell division follow daily timing linked to rotation and sunlight. This means that the planet's motion has literally written itself into the biochemistry of life. The spin of the Earth became the metronome of evolution, steady, reliable, yet never entirely still. If we ever discover life on another world, scientists will look first for the same pattern. A planet that rotates, tilts, and breathes. Because motion creates variation, and variation is the mother of complexity. The moon, our silent companion, still tugs gently on Earth's oceans, slowing the planet's spin by about 1.7 milliseconds per century. It's a small change, but over millions of years it adds up. The days grow longer imperceptibly. In the age of the dinosaurs, a day lasted about 23 hours. Hundreds of millions of years from now, it will stretch beyond 25. Somewhere in that slow drift lies a lesson. Motion evolves too. Even the spinning of a planet is not eternal. It breathes, changes, adapts. The rhythm of Earth is alive, slowing, but still singing. Every part of Earth's motion serves a purpose. Its tilt creates seasons. The spin moderates the climate. Its magnetic field protects. Its orbit synchronizes energy. Together, they form an orchestra of stability. Delicate enough for oceans to stay liquid, air to stay breathable, and life to flourish. Change one piece too much and the harmony would break. Speed up the spin and days shorten. Plants and animals lose their cycles. Slow it too far and temperature extremes destroy habitability. In the cosmic sense, we live inside a perfect compromise, a balance sculpted by motion. Perhaps that's the quiet paradox of existence. We learn calm from a planet that never rests. Every sunrise you see is a reminder that the world beneath you is spinning ceaselessly, gracefully. A dance you're part of, whether you notice or not. When you close your eyes tonight, remember, the air you breathe has crossed oceans because of the Earth's rotation. The warmth that touches your skin has been balanced by that motion. And your heartbeat, steady and circular, is one more echo of the same cosmic rhythm. Spin didn't just make life possible. It made life beautiful. The Earth turns not because it must, but because life needs its rhythm. And every breath we take is one small note in that endless song. If you could float far above the Earth, high enough to see the whole planet turning beneath you, you would notice something extraordinary. Time itself moves differently up there. Your watch would tick a little faster than one on the surface. And if you could orbit near a rapidly spinning black hole, time would almost stop. This isn't magic or science fiction. It's one of the quietest, strangest truths in physics. Motion and gravity can bend the flow of time. And when motion becomes rotation, when space itself begins to twist, the effect deepens into something almost poetic. For most of history, we thought of time as absolute, a steady river flowing the same for everyone, everywhere. But in 1905, Albert Einstein changed that forever. He showed that time and space are not separate. They form a single, flexible fabric called space-time. And when something moves fast or has great mass, that fabric bends. A massive body like Earth curves space-time around it. That's what we call gravity. And a rotating mass doesn't just bend space downward. It drags it slightly along, twisting it like water spiraling around a drain. This effect is known as frame dragging. Imagine stirring honey with a spoon. The thick liquid near the spoon begins to move, pulled by the rotation. Space behaves similarly. When a planet, star, or black hole spins, it drags space-time around with it. This idea was first predicted by two Austrian physicists, Joseph Lenz and Hans Thüring, in 1918. For decades, it remained only a theory, too subtle to detect. But in 2004, NASA's Gravity Probe B satellite finally confirmed it. The gyroscopes aboard showed that Earth's rotation slightly twists the space-time around it by a tiny fraction of a degree each year. This minuscule but real. Closer to massive objects, the twisting becomes profound. Near a rapidly spinning black hole, space doesn't just curve. It whirls, dragging everything, even light, along with it. To resist that pull, an object would have to spin faster than the speed of light, which is impossible. So everything near the black hole must join the dance. In this region, called the ergosphere, space and time are literally being stirred together. Not all black holes spin, but most seem to. And the ones that do are called Kerr black holes, after physicist Roy Kerr, who described them in 1963. Unlike the simple point black holes of early theory, a Kerr black hole has structure. It drags space into a rotating funnel. Outside the event horizon, the ergosphere forms like a glowing halo, where energy and matter can orbit in impossible ways. Particles here can gain or lose energy, even extract power from the black hole's spin, a process known as the Penrose mechanism. It's one of the few ways physics allows energy to be drawn from a black hole without breaking any laws. Near such an object, time slows to a crawl. To an outside observer, a clock near the black hole's surface would tick infinitely slower. Inside that gravitational whirlpool, seconds stretch into eternities. But for anything falling in, time feels perfectly normal, a paradox that lies at the heart of relativity. In truth, time doesn't stop. It just flows differently depending on where you stand or how fast you move. We don't need to visit a black hole to feel Einstein's universe. We live in it every day. Your phone, your GPS, and even your wristwatch depend on relativity to work. Satellites orbiting Earth move fast and experience weaker gravity, so their clocks tick about 38 microseconds faster per day than clocks on the ground. That may sound tiny, but without correcting for it, GPS would drift by several kilometers each day. So engineers constantly adjust the satellite's time, quietly syncing them to a reality where motion bends time. Even your feet and your head age at slightly different rates because your head is a little farther from Earth's center of gravity. The difference is unimaginably small, about 90 billionths of a second per year, but it's there. Time, it seems, is always local. It's tempting to imagine that spinning itself creates gravity. But the truth is subtler. Gravity arises from mass, from the way mass curves spacetime. Rotation modifies that curvature. It doesn't cause it. Think of mass as pressing into a soft fabric, and spin as twisting that depression slightly. Still, in extreme cases like neutron stars or black holes, that twist becomes so strong that space behaves like a whirlpool. Matter orbiting too close can be torn apart, forming glowing accretion disks that radiate X-rays and light. In those places, motion and gravity are inseparable, two ways of describing the same distortion of spacetime. Even here, in our quiet solar system, frame dragging has subtle consequences. Einstein's equations predict that Earth's rotation slightly alters the orbits of satellites and planets, just enough to measure with precise instruments. It's one of the final tests of general relativity that continues to hold. Every orbit, every rotation, every tiny precession in the cosmos is part of that same cosmic choreography, a dance choreographed by geometry itself. Einstein once said, "The distinction between past, present, and future is only a stubbornly persistent illusion." When you understand time as a fabric, this begins to make sense. Rotation doesn't merely delay time, it warps its texture. Imagine stretching a rubber sheet and then twisting it. The twist doesn't just move points around, it changes how the sheet connects one place to another. That's what spin does to space-time. It gives the universe texture. Without rotation, everything would be smooth, featureless, and perhaps timeless. Spin adds direction, asymmetry, and therefore meaning. Many have wondered if extreme rotation could bend time into a loop, a closed time-like curve, where the future connects back to the past. Einstein's equations do allow such solutions under certain conditions, like in the Gödel universe, a theoretical model that rotates as a whole. But most physicists view those as mathematical curiosities, not realities. In the observable universe, such conditions would require impossible densities or energies. Still, the idea remains fascinating, that enough motion could fold time back on itself. Even if nature forbids it, mathematics reminds us that time is not rigid. It can bend, stretch, and dance even if it never breaks. When you sit in stillness, watching the stars drift overhead, you are actually moving, rotating with the Earth, orbiting the sun, circling the galaxy. Your heartbeat, your breathing, your thoughts, all have rhythm. All are rotations in miniature. Perhaps that's why we experience time not as a static quantity, but as flow. We are part of the same geometry, small beings made of spinning atoms, living on a spinning world, inside a spinning universe. Maybe that's why meditation feels timeless, because in that stillness, we finally align with motion so complete that it feels like rest. The slower we perceive time, the closer we come to understanding what Einstein meant. That time is not a clock ticking outside of us. It is the space we move through, and the way we move changes it. If rotation can bend time, perhaps every moment we live is slightly curved too, shaped by the invisible whirl of motion that never stops. Each turn of the Earth, each beat of the heart, each orbit of the moon is part of the same slow spiral, a pattern written into spacetime itself. And somewhere, deep inside that fabric, time is not counting seconds. It's listening to the rhythm of the universe turning. Time does not flow, it spins, and in its spiral we find both motion and peace. Listen closely to the smallest clock in the universe. It isn't the one on your wrist, nor the one hanging on your wall. It's motion itself. Everything that measures time turns in some way. Earth spins to create days, Earth orbits the sun to create years, and even deeper, the atoms that define a second vibrate to an inner quantum rhythm. If spin can bend the flow of time, making it run faster or slower depending on speed and gravity, then the next question feels natural. Who controls the spin? Physics gives a surprisingly calm answer. No one. Spin is passed on and conserved. The standard tick of time we use isn't taken from sunrise or sunset. It comes from something far more precise. Atomic transitions. A second is defined as 9,192,631,770 oscillations of the microwave radiation emitted during a hyperfine transition of the cesium-133 atom. In simple terms, one quantum spin beat repeats with perfect consistency, turning microscopic rotation into a macroscopic measure of time. There's a quiet beauty in this. We measure the rhythm of the world through the internal motion of matter, not physical spinning in space, but the intrinsic angular momentum of particles and energy states. That quantum heartbeat forms the foundation of the atomic clocks that keep GPS, the internet, and global time itself synchronized. Relativity works silently behind your daily routine. GPS satellites orbit Earth quickly and far above its surface, so two effects appear. Because gravity is weaker at altitude, their clocks tick faster by about plus 45 microseconds per day, general relativity. Because they're moving fast, time for them slows down by roughly minus 7 microseconds per day, special relativity. Combined, that's a net plus 38 microseconds per day. If engineers didn't constantly correct for it, GPS would drift several kilometers every 24 hours. So the entire network keeps adjusting itself. A quiet reminder that the sky and the ground live in slightly different times, harmonized only through mathematics. Even here on Earth, time flows a little unevenly. A clock placed higher up, farther from Earth's center, experiences weaker gravity and thus ticks slightly faster than one near the ground. Meanwhile, Earth's rotation speed, slightly faster at the equator, produces a faint relativistic slowdown that mostly cancels the gravitational difference at sea level. On the reference surface, the geoid or mean sea level, the two effects nearly balance. The difference that remains is so small it can only be measured by the world's most sensitive instruments. Still, it proves something profound. Time is local, it depends on where you stand and how you move. On a cosmic scale, the spin of Earth, the Sun, and all planets comes from the conservation of angular momentum during the solar system's birth. A vast cloud of gas and dust collapsed under gravity, spinning faster as it shrank, just as a figure skater spins faster when she pulls in her arms. Once rotation begins, in the nearly frictionless vacuum of space, it continues for eons without needing a push. On the quantum scale, spin isn't about physical rotation. It's an intrinsic property of particles, like mass or electric charge. From this quantum spin emerge rules such as the Pauli exclusion principle, which says two electrons can't occupy the same state. That rule underlies chemistry and therefore life itself. In other words, spin defines structure at small scales and rhythm at large scales. Physics answers simply, the universe does through symmetry and conservation. Angular momentum is conserved. It can't be created or destroyed, only transferred. The moon's tides slowly pull rotational energy from Earth, lengthening the day by about 1.7 milliseconds per century. That lost spin becomes orbital momentum, pushing the moon 3.8 centimeters farther away every year. In galactic collisions, spin is redistributed. Some becomes the orbital motion of stars, some turns into the swirling of interstellar gas and magnetic fields, and some dissipates as gravitational waves when black holes merge. There is no cosmic hand turning a dial, just a self-balancing exchange where motion in one place becomes stillness in another. Every clock humanity has ever built is just an echo of larger spins. The second atomic spin rhythm, cesium-133, the day, one rotation of Earth. The year, one revolution around the Sun. The age, Milankovitch cycles of axial tilt, orbital shape, and precession shape the climate over tens of thousands of years. The galactic year, one full rotation of the Milky Way every 230 million years. These clocks are nested within one another, synchronized by gravity, magnetism, and angular momentum transfer. Time, seen from above, is no longer a line. It's a symphony of rotations. Some cosmological studies explore whether the entire universe might have a small, global rotation or a preferred direction. Evidence so far is inconclusive. Any such effect, if real, is extraordinarily subtle and doesn't contradict standard cosmology. It's wiser to say, there are hints of large-scale asymmetries, but no confirmed proof. What we do know is that tiny imperfections, symmetry breakings, CP violations, are enough to create the entire structured, spinning cosmos we see today. If spin controls time, then the conductor of that rhythm is the law of conservation itself. Every tidal pull, every galactic collision, every photon carrying angular momentum, all are ways the universe keeps its energy in motion while preserving balance. You are part of that same melody. Your electrons spin. The Earth beneath you spins. The moon drifts outward, borrowing a little of our day. The galaxy turns, carrying us through cosmic seasons. So who controls spin? No one needs to. Equilibrium does. Conservation does. And within that endless exchange, time emerges, not as a number, but as a breath. If spin controls time, then balance controls spin. And through that harmony, the universe keeps turning, silently, endlessly, at peace. If you look at the universe from far enough away, it seems beautifully balanced, galaxies swirling in every direction, the cosmic microwave background nearly uniform, the laws of physics identical wherever you go. And yet, the closer you look, the more you realize, nothing is perfectly symmetrical. Every atom, every star, every heartbeat exists because, at some point, something slightly broke that perfect balance. It's a paradox at the heart of everything. Perfection is stillness. Imperfection is life. At the very beginning, the first fractions of a second after the Big Bang, the universe was nearly flawless. Energy was evenly distributed, and all the fundamental forces were unified into one. No direction was preferred. No imbalance existed. Physicists call this state perfect symmetry. But perfect symmetry cannot evolve, because in a world where every point is identical, nothing ever happens. And so, something changed. A small fluctuation, maybe quantum, maybe inevitable, caused a region of space to behave just slightly differently from its surroundings. That imperfection grew, like the first crack in ice, until symmetry shattered. And from that fracture, motion, time, and structure began. In the first trillionth of a second, as the universe expanded and cooled, the unified forces began to separate. A gravity detached first, setting the stage for space and time themselves. Then the strong nuclear force split away, binding the particles that would one day form atomic nuclei. Finally, the electroweak force is divided into electromagnetism and the weak nuclear force through a process triggered by a field known as the Higgs field. This unfolding, sometimes called spontaneous symmetry breaking, didn't just separate forces. It gave particles mass, direction, and identity. Before this moment, particles were like waves on an ocean without texture, indistinguishable and massless. After the Higgs field settled, the universe suddenly became full of differences. Heavy and light, positive and negative, matter and radiation. Symmetry broke, and the universe took its first breath. In mathematics, symmetry is elegant, but in nature, too much symmetry is sterile. A perfectly balanced universe would remain an eternal field of energy, without stars, without atoms, without us. Breaking symmetry is what allows structure to emerge. It's the same principle that causes snowflakes to form unique patterns, or living cells to divide into different shapes and roles. The smallest deviation becomes the seed of creation. In physics, this idea isn't just poetic, it's essential. Without tiny asymmetries in the early universe, matter and antimatter would have annihilated each other completely, leaving behind only light. Instead, for every billion particles of antimatter, there was one extra particle of matter. That infinitesimal imbalance, 1 in a billion, is the reason the stars exist, and the reason you are here to think about them. Scientists call this miracle baryogenesis, the process that made matter win over antimatter. We don't yet know exactly how it happened, but we know what it required. 1. Interactions that violate symmetry between matter and antimatter called CP violation. 2. Conditions far from thermal equilibrium. And 3. Processes that change baryon number, in other words, that allow the creation of more particles than antiparticles. These sound abstract, but they mean something simple. In the earliest universe, under immense energy, symmetry wasn't perfect, and that imperfection favored matter slightly. That slight bias became the entire visible cosmos. If symmetry had remained absolute, the universe would still exist, but it would be empty, flooded only with light. So, yes, the universe may have begun not despite imperfection, but because of it. Imagine a perfectly round ball balanced on top of a hill. At first, it could roll in any direction, complete symmetry. But the moment it moves, it chooses a side. That single choice defines everything that follows. This is the simplest image of spontaneous symmetry breaking. In the early universe, the Higgs field was like that ball, perfectly balanced, with no preferred direction. But as space expanded and cooled, the field rolled down into a stable state, giving mass to particles that interacted with it. From that moment on, there was no going back. Symmetry had broken, and the universe had chosen its shape. If the word broken sounds tragic, it shouldn't. Because every form of beauty, from galaxies to snowflakes to human faces, comes from imperfection. Symmetry breaking is the reason the universe has contrast, color, and complexity. It's the reason gravity could clump matter together to form stars, which forged heavier elements, which built planets, oceans, and living things. In that sense, the Higgs field isn't just a scientific curiosity. It's the artist's brush that painted variety across the cosmos. The entire story of creation is a story of difference arising from balance. Physicists sometimes talk about fine-tuning, how the constants of nature seem precisely set for life to exist. But perhaps it's not tuning at all. Perhaps it's tolerance. The universe doesn't demand perfection. It allows small deviations, and from those deviations, creativity unfolds. Even today, perfect symmetry is rare. Atoms vibrate unevenly. Galaxies cluster asymmetrically. Even time itself doesn't flow at a constant rate across all of space. But those tiny mismatches are not flaws. They are the engine of evolution. If the early universe was born from broken symmetry, then what keeps it stable now? The same principle balanced through motion. The forces that once split now interact delicately, exchanging energy to maintain cosmic equilibrium. Gravity still pulls, but expansion still pushes. Electromagnetism repels, but the strong force binds. Every moment, the universe negotiates between opposites. A cosmic conversation that has never stopped since that first asymmetry appeared. Perhaps broken symmetry is just another way of saying the universe learned to move. When you look at yourself, your heartbeat, your breath, your thoughts, you are looking at the legacy of that first imbalance. Every molecule in your body exists because the universe, long ago, decided not to stay perfect. If everything had been equal, there would be nothing at all. But because there was a whisper of difference, creation began. Maybe that's the universe's greatest secret. Perfection is not the goal. Perfection is silence. And life, all life, is what happens when silence is broken. The universe did not fall from symmetry. It bloomed from it. A single imperfection unfolding into everything that is. Look up into the night sky. Each star you see, quiet, distant, ancient, belongs to a great spiral of motion. Our own Milky Way is one of them. A flat disk of hundreds of billions of stars, all circling a common center, spinning once every 230 million years. And yet, there's a secret hidden in that elegant dance. If you calculate the pull of gravity from all the visible stars and gas, the galaxies you see should not be able to hold together. They're spinning too fast. By the laws of motion, we know they should have already torn themselves apart. But they haven't. They remain whole, luminous, serene, as if something unseen is holding them in its arms. Imagine you're standing at the edge of a spinning carousel. The faster it turns, the stronger the outward pull. For a galaxy, stars far from the center should feel this pull more strongly than the inward tug of gravity. Eventually, they should drift away into the cold dark between galaxies. But when astronomers measured this in the 1970s, led by Vera Rubin and Kent Ford, they found something astonishing. The outer stars were moving just as fast as the inner ones, not slower, as Newton's laws predicted. If only visible matter existed, the galaxies should fly apart. But they don't. They hold their shape as if wrapped in an invisible force. Something unseen adds extra gravity. Something vast. Something that doesn't shine. This was the beginning of one of the greatest puzzles in modern science. Dark matter. Not dark because it's sinister, but because it doesn't emit or reflect light. It doesn't glow, it doesn't absorb, it simply is there, silent, transparent, and gravitationally powerful. Today, we believe that 85% of the matter in the universe is this invisible kind. It doesn't make stars or planets, but it shapes them all. It builds the cosmic web, vast filaments of structure stretching across billions of light years, connecting galaxies like pearls on invisible threads. Without it, galaxies might never have formed at all. Gravity from normal matter alone would be too weak to pull things together before the universe expanded beyond reach. Dark matter, whatever it is, gave structure a chance to exist. Despite decades of searching, we still don't know what dark matter truly is. It might be exotic particles like WIMPs, axions, or sterile neutrinos. It might even be a sign that our understanding of gravity itself is incomplete. Experiments deep underground and satellites in orbit have searched for signals. Tiny collisions, faint decays, distortions in starlight. So far, the universe keeps its secret well. But even if we can't see dark matter directly, we can trace its fingerprints. We see its pull in gravitational lensing, where light from distant galaxies bends around invisible masses. We feel its structure in galactic rotation curves, where every orbit betrays the same hidden shape. We witness it in collisions of galaxy clusters like the famous Bullet cluster, where ordinary matter lags behind but the invisible mass keeps moving ahead. It's not imagination, it's geometry, written into the very shape of space. If you could step outside the universe and see it all at once, you'd find it looks like lace, a vast cosmic web of filaments and voids. At each intersection, galaxies gather, drawn by invisible gravity. Simulations show how dark matter sculpted this pattern. Tiny fluctuations in the early universe, faint ripples in the cosmic microwave background, became anchors for gravity to grow around. Gas fell into these wells, cooled, and ignited stars. From invisible beginnings came the shining architecture of galaxies. It's as if an unseen artist sketched the outlines, and the stars merely filled in the light. Every galaxy is surrounded by a dark matter halo, a massive, roughly spherical cloud extending far beyond the visible disk. Our own Milky Way's halo stretches hundreds of thousands of light-years, containing perhaps 10 times more mass than all its stars combined. These halos are what keep the galaxy stable. When a star orbits near the edge of the disk, it's not just feeling the gravity of nearby stars, but of this entire invisible cocoon. The result is balance, motion without collapse, speed without disintegration. Galaxies exist because something unseen holds the edges when everything inside wants to fly apart. Some scientists have proposed that maybe gravity itself behaves differently on cosmic scales. The theory, called modified Newtonian dynamics, suggests that the laws of motion might shift when accelerations are extremely small. In some cases, it can reproduce galactic rotation without needing dark matter. But the deeper we look into galaxy clusters, the cosmic microwave background, and gravitational lensing, the more consistent the evidence for unseen mass becomes. Still, humility remains part of science. Perhaps the truth is a mixture, part dark matter, part new physics, part mystery. As one astronomer said, we're still learning the handwriting of gravity. There's a strange comfort in knowing that most of the universe is invisible. It reminds us that existence is larger than perception. The light we see, stars, nebulae, galaxies, is just the surface pattern of something deeper, quieter, and more stable. The galaxies spin, the stars whirl, but the dark scaffolding underneath holds the rhythm steady, like a heartbeat beneath a dancer's motion. Maybe that's what balance truly is. Not the absence of motion, but the harmony between what moves and what anchors. Dark matter doesn't burn, doesn't shine, doesn't speak, but without it, nothing bright would last. It's the invisible structure that allows the luminous to exist. It's the silence that gives music space to breathe. So perhaps the question isn't what holds galaxies together, but why they stay together at all. The answer, as always, seems to lie in balance between visibility and mystery, between matter and motion, between knowing and not knowing. The galaxies don't fight their spin. They lean into it, trusting an unseen hand to hold their form. And maybe we're not so different. We too live in motion, held by things we can't quite see. Gravity, memory, love, time. When you gaze into the night sky, the stars seem scattered like dust. But in truth, every one of them is held by invisible threads, connected across billions of years. You, sitting here, are part of that same fabric, a moment of consciousness woven into a web of unseen forces. Dark matter may be nameless, but its touch is everywhere. Every breath you take, every sunrise you see, every thought that crosses your mind, all unfold within the stability it built. The galaxies spin, and yet they stay whole. Not because they resist the void, but because the unseen keeps them steady. The stars are only the notes. The dark is the melody that holds them together. Look closely at life, at the curve of a leaf, the spiral of a shell, the twist of your DNA. Every living thing, from the simplest cell to the beating heart of a human being, follows a pattern, a direction. It's as if existence itself has chosen a side. And that side is not random. All molecules that make life possible, the amino acids that build proteins, the sugars that form our genes, are not symmetrical. They come in two mirror image forms, like left and right hands. In chemistry, we call this chirality. But in life, only one hand is ever chosen. Every amino acid in your body is left-handed. Every strand of DNA and RNA twists to the right. It is one of the strangest facts in all of biology. The universe allows both possibilities, yet life picks only one. If life's chemistry were purely random, we might expect both forms to exist equally. But our world shows only a single direction, a cosmic preference written deep in every cell. The question is, why? For decades, scientists have searched for an answer, and the more they look, the more the mystery leads outward, beyond the Earth, beyond biology itself, into the structure of the cosmos. Because perhaps the same ancient spin that set galaxies in motion also set the twist of life. Long before Earth was born, before the first oceans and clouds, the universe was already turning. Galaxies spiraled, stars were born, and magnetic fields coiled through clouds of gas and dust. Light itself, traveling across those fields, became polarized, vibrating slightly more in one direction than another. When that light struck molecules floating in interstellar space, it could subtly favor one mirror image form over the other, one hand over the other, and over millions of years, that tiny bias became amplified, setting the direction that life would one day follow. It is a breathtaking idea, that the shape of your DNA may be an echo of ancient starlight, a molecular memory of how the universe first spun. Evidence for this connection is scattered like cosmic breadcrumbs. In 1969, a meteorite fell near Murchison, Australia. Inside it, scientists found over 70 kinds of amino acids, many of them showing a faint but measurable excess of the left-handed type. These molecules were older than Earth itself. They had formed in the darkness of interstellar space and carried within them a subtle imbalance, a whisper of a symmetry written before life began. That imbalance matches the very one found in every living organism today. When we send spacecraft to study comets, asteroids, and the dust between the stars, we keep finding the same pattern, the same preference. In 2014, when the Rosetta mission's lander touched down on Comet 67P, it detected complex organic molecules, precursors of amino acids, showing signs of this same bias. It seems that the direction of life was not chosen on Earth. It was inherited from the cosmos. But where did that first bias come from? One possible clue lies like light itself. Light waves can be circularly polarized, meaning they twist as they travel, like miniature spirals of energy. When such twisted light interacts with certain molecules, it can destroy one mirror form slightly more efficiently than the other. Over time, this leaves behind an excess, a preference for one hand of chemistry. Astronomers observing star-forming regions in the Orion Nebula and the Taurus molecular cloud have detected circularly polarized light streaming from newborn stars. This light is sculpted by magnetic fields twisted by rotation. It is literally starlight with a spin. And when that spinning light falls upon interstellar dust and frozen molecules, it may imprint its direction into chemistry itself. Perhaps that's where it began, not in some primordial soup on Earth, but in the gentle twist of polarized light billions of years ago. The universe, already spinning on every scale, passed its motion into matter, from galaxies to atoms, from starlight to DNA. Even at the quantum level, nature shows the same bias. Certain particles, like neutrinos, always spin in one direction, a phenomenon known as parity violation. This tiny asymmetry in the laws of physics may be the root of all others, cascading upward from the smallest particles to the largest living forms. When physicist Qianxiong Wu proved this in her famous beta decay experiment in 1956, she revealed something profound. The universe is not perfectly symmetrical. Left and right are not treated the same. Even nature itself seems to prefer a particular direction. That realization changed everything, because it suggested that the handedness of life, our left-handed amino acids and right-handed DNA, might not be a coincidence. It might be part of a grand cosmic pattern, stretching from subatomic particles to stars and living cells. On Earth, this handedness appears everywhere once you start to notice it. Hurricanes swirl counterclockwise in the northern hemisphere, clockwise in the southern hemisphere, guided by the Coriolis effect, born from the planet's spin. Ocean currents twist, tree branches spiral, and even the shells of snails curve in consistent directions. Life seems to reflect the spin of the world that gave it birth. But chirality in biology is deeper than weather or form. It defines how molecules fit together, how enzymes fold, how genetic codes are read. A molecule with the wrong hand often cannot interact properly. Just as a left glove doesn't fit a right hand, a right-handed amino acid can't build a left-handed protein. So, once life chose one direction, it had to stick with it forever. Change the twist, and the entire harmony breaks. That irreversible choice, the one-sidedness of life, became the foundation of biochemistry. And it may have been written not by chance, but by physics, by light, magnetism, and spin, the same elements that govern stars. When scientists simulate this in laboratories, they find that even a small imbalance in polarized light can lead to measurable chirality in organic compounds. The twist of photons can shape the twist of molecules. The smallest rotation can determine the architecture of life. So when we ask whether the universe's spin decides the direction of life, the answer seems to whisper. Perhaps it does, gently, invisibly, but profoundly. Not as a command, but as a tendency, a faint nudge that all matter remembers. The same spiral that turns galaxies may echo in the double helix of your DNA. There is poetry in that. The atoms in your body were forged in stars. The motion that shaped your cells began in the rotation of the cosmos. You are made not only of stardust, but of starlight spin. Even now, light travels through space carrying that memory, polarized, twisted, ancient. And when it reaches Earth, it still dances across oceans, leaves, and eyes. The same cosmic rhythm, reflected in every living curve. In this way, the universe never stopped creating. Its rotation still resonates through time, through light, through life. From the whirl of galaxies to the swirl of seashells to the spiral inside your cells, everything is turning in quiet agreement. If you hold your breath and listen, you might feel it, that subtle motion that threads through everything that exists. It's not something we can see, but we are part of it. We are born of it. We are the continuation of its turn. So perhaps the secret of life's direction isn't hidden in DNA alone, but in the universe itself, a whisper of rotation that began 13.8 billion years ago, still flowing through light, through atoms, through you. And if you look closely enough, every spiral, from the galaxy above to the helix within, seems to say the same thing. Life is not separate from the universe's motion. It is how the universe remembers its spin. Every motion you see, every orbit, every wave, every breath, comes from something that once began to turn. The planets spin, the stars rotate, galaxies swirl like cosmic storms frozen in time. Even the tiniest particles, electrons, quarks, neutrinos, carry spin within them, a memory of motion so ancient that it has no beginning. But what happens when that motion fades? Will there come a time when the universe, once filled with spirals of light and energy, simply slows and forgets how to turn? The story begins not with stillness, but with speed. In the first seconds after the Big Bang, everything expanded, collided, and spun at unimaginable scales. That initial turbulence seeded the motion we see today. Galaxies rotating, clusters orbiting, stars twirling in silent rhythm. Yet all motion comes at a cost. Every rotation transfers energy, and every transfer leaves a trace. Heat, radiation, entropy. Slowly, invisibly, the universe has been trading order for calm. Entropy, the measure of disorder, is the quiet accountant of the cosmos. Keeps track of how usable energy becomes scattered, how movement dissolves into balance. From burning stars to collapsing black holes, every process pays into this cosmic ledger. And someday, perhaps, that ledger will close. As the universe expands, galaxies drift farther apart, like dancers moving away from the center of a fading waltz. The stars within them burn their last fuel, turning hydrogen into heavier elements and then into dust. Supernovae explode, scattering matter into space, the ashes from which new stars are born. But even that rebirth has a limit. One day, the universe will run out of the easy fuel that makes new suns. Star formation will slow, then stop. Galaxies will dim. The night sky, once vibrant with motion, will begin to fade. Black holes will remain, spinning silently, the last great engines of the cosmos. Their rotation is the most intense in existence, twisting space and time themselves into spirals of gravity. But even black holes are not eternal. Over eons beyond comprehension, they will leak away energy through a faint glow, hawking radiation, and evaporate into nothing. When that happens, even the last traces of spin will dissolve into the background of the universe. In that far future, there will be no galaxies, no stars, no motion large enough to measure. Only thin radiation, spread evenly through an ever-expanding space. No direction, no rhythm, no change. The universe will have reached what physicists call heat death. Not a violent end, but a quiet surrender. Every gradient will be gone. Every wheel will have stopped. The cosmos will have forgotten how to move. And yet, even that stillness has its own kind of poetry. Because the energy that once drove stars and galaxies doesn't disappear, it only transforms. The spin of the past becomes the calm of the future. Motion becomes memory. In that sense, the end of spinning is not the loss of meaning, but the return of balance. Some scientists imagine other endings. Perhaps dark energy, the mysterious force driving cosmic expansion, will continue to accelerate, pulling galaxies apart faster and faster until atoms themselves are torn asunder. A big rip, a universe unraveling from within. Or maybe expansion will one day slow and reverse, collapsing everything back toward a final big crunch, where gravity reclaims every particle and light bends back into itself. In that fiery end, the universe could spin once more, a final rotation before rebirth. We don't yet know which story is true. The data still whispers, but does not shout. For now, the evidence suggests a slow fade. A cosmos that continues to expand forever, growing colder, emptier, and softer with time. But perhaps forgetting isn't the right word. The universe doesn't truly forget. It remembers in different ways. Even when the last star flickers out, the laws that allowed spinning to exist will remain written into the fabric of space. The equations of motion, the conservation of angular momentum, are eternal inscriptions, the silent geometry of existence. They do not vanish. They only sleep. Maybe that's what eternity means, not endless activity, but endless potential. The capacity for motion even when motion has ceased. like a song paused between notes, waiting to be played again. If our universe is part of a larger cycle, one of many births and deaths, then perhaps spin too is reborn. From the ashes of heat death, quantum fluctuations could stir again, like ripples in an infinite sea. A new universe could bloom from the quiet vacuum, carrying within it the faint memory of motion, a spark that begins everything anew. In that next beginning, particles would once again acquire spin, galaxies would form, stars would light the dark, and time would find its flow. Each turning universe may inherit the whisper of the last, a pattern carried not by matter, but by mathematics, by the very rules that allow balance and imbalance to exist. And so, the question isn't whether the universe will forget how to spin, but whether spin itself ever truly ends. Look around you now. The Earth is still turning. The moon still orbits. The stars still move across the sky. Every rotation you witness is a continuation of that first motion, the one that began when time itself began. You are surrounded by echoes of the universe's earliest spin. You are made from it. Atoms within you were once part of stars that revolved around the heart of galaxies, that spun from clouds born in the universe's youth. Even your thoughts, the electrical currents moving through your brain, are tiny patterns of motion, shaped by the same physical laws that guide planets and photons. You are not separate from the cosmic rotation. You are one of its ongoing spirals. So when we speak of the universe forgetting how to spin, we are really talking about the slow return to equilibrium, a final exhalation after a long and wondrous breath. Perhaps that is not tragedy, but peace. The universe does not die, it rests. The stars do not vanish, they dissolve into memory. And motion, once begun, leaves an imprint that cannot be undone. If the end comes not with a bang, but with a whisper, that whisper will still carry the story of everything that ever turned, ever burned, ever was. Even when the galaxies fade and the light grows thin, the rhythm of creation, the symmetry, the breaking, the turning, will remain written in silence. So maybe the universe won't forget how to spin. Maybe it will simply close its eyes for a while and remember, in stillness, how beautiful it was to move. One day, the stars will rest, but the memory of their turning will still hum quietly in the dark. A lullaby the universe hums to itself. Close your eyes for a moment. Feel your breath rise and fall. That rhythm, the simple motion of inhale and exhale, is not separate from the universe. It is a smaller echo of something much older. The rise and fall of galaxies, the pulse of time, the endless dance of matter and energy in motion. When you breathe, you are repeating a pattern the universe has known since its beginning. Contraction and expansion, silence and vibration. Your chest moves the way space once moved, when it stretched outward in the first instant of creation. The rhythm that keeps you alive is the same rhythm that keeps the cosmos unfolding. If everything in the universe spins, and if every spin is a form of memory, then perhaps we, too, are part of that memory. Perhaps consciousness itself is how the universe remembers that it is still moving. From the smallest particle to the largest cluster of galaxies, motion is everywhere. Electrons orbit atomic nuclei, planets circle stars, stars orbit galactic centers, and galaxies turn within a cosmic web that itself may drift like a slow tide through space-time. Each layer is both separate and connected, bound by the same law, angular momentum, the persistence of spin. Nothing that begins turning ever truly stops. It only changes form. Inside your body, that same principle holds. The atoms in your cells once spun in the heart of stars. Those stars are in the arms of spiral galaxies. and those galaxies were born from tiny ripples of energy in the infant universe. You are, in a very literal sense, made of ancient motion, matter that remembers how to turn. Your heartbeat, your thoughts, even your sleep, all of them are patterns. Rhythms of repetition, energy cycling between states. A neuron firing is not so different from a star flickering. Both are transfers of energy, both create order from chaos, and both are acts of remembrance. When you think, you are not generating something new. You are echoing a pattern that has always been, awareness itself, folded into matter, unfolding again. Sometimes we imagine ourselves as separate from the cosmos, small observers looking outward at infinity. But in truth, there is no boundary. The same fabric that curves around stars curves through your veins. The same quantum fields that give particles their spin are humming inside you. When you think about the universe is thinking about itself through you. Every mind, every awareness is like a mirror turned inward toward creation. It reflects light that has traveled billions of years and gives that light meaning. The atoms that once drifted in darkness now speak, wonder, and remember. That is what consciousness might be, not an exception to nature, but its continuation. In every language, in every story humanity tells, there is an instinct to connect motion with life. We say time flows, love moves, grief circulates, thought spirals. We sense intuitively that to be alive is to be in motion. Stillness, even the stillness of meditation, is never truly motionless. It is the steady turning of awareness inward, the way a planet turns toward its own night side. And perhaps that's why we are drawn to look up at the stars. Somewhere deep in memory, we know that what we see is a reflection of ourselves, not in form but in pattern. We are built from the same spin, the same light, the same unfolding that has shaped everything since the first moment. In physics, there is a principle called conservation of information, the idea that no information in the universe is ever truly lost. Even if stars burn out and galaxies fade, the data of their existence remains written in the structure of space itself. Every atom carries within it the trace of all that has ever been. In that sense, memory is not something human, it is cosmic. We do not hold it, we are it. When you recall a moment from your life, a voice, a touch, a piece of music, what you are really doing is setting matter in motion. Tiny electrical currents reawaken in your brain, repeating a pattern formed long ago. That is how the universe remembers, through rhythm, through repetition, through energy finding its way back into awareness. The spiral is the perfect symbol for that remembrance. From hurricanes to seashells, from galaxies to DNA, it recurs again and again, an infinite loop of expansion and return. A spiral never ends. It only widens or tightens, always moving, always remembering. You are built in its image. You are the spiral that learned to think. And maybe this is why humans create art, tell stories, and search for meaning. It is our way of mirroring the universe's original motion, to take chaos and turn it into pattern, to turn energy into form, to turn silence into song. Each act of creation is a small continuation of that first act of imbalance that began everything. When you write or love or dream, you are participating in the universe's way of remembering itself. Even sleep, the quiet turning inward of the mind, follows this pattern. Each night, as you drift between waking and dreaming, your consciousness cycles like a small orbit, recharging, resetting, recalling. Dreams are not separate from physics. They are the way awareness reorganizes its own energy, the way it remembers that it belongs to something larger. So when we ask, are we the universe remembering its own motion? Perhaps the truest answer is yes, and more than yes. We are the memory, the motion, and the witness all at once. We are not merely passengers in this turning cosmos. We are expressions of its spin, condensed into thought and form. We are how the universe looks back at itself and smiles. Look up tonight, and every point of light you see is a record of motion, a photon traveling across billions of years to meet your eye. When it reaches you, that journey ends and a new one begins. An impulse in your brain, a flicker of awareness that says, I see. In that instant, two forms of motion, cosmic and human, become one. The light's travel, your recognition, both are part of the same process. The universe remembering that it exists. In the end, maybe memory and motion are the same thing. To move is to remember, and to remember is to keep moving. Every spin, every orbit, every heartbeat is a repetition of the same truth. Nothing ever truly stands still. Even silence vibrates. Even darkness glows faintly. Even death is just another transformation of energy into a different kind of spin. And if one day, far in the future, the universe does grow quiet, if every galaxy drifts beyond sight, and every star falls asleep, that will not be an end. Because even in perfect stillness, the laws that once made motion possible will still exist, written into the emptiness like an unplayed song. And perhaps one day that song will begin again. For now, you are here, a fragment of the cosmos aware of itself, breathing, thinking, turning softly in the flow of time. You are not separate from the stars, nor from the silence that surrounds them. You are what the universe has become, so it could feel its own rhythm, so it could remember its own spin. When you close your eyes tonight, imagine the galaxies turning slowly around you, the quiet arms of light, the invisible halo of gravity, the great spiral of being. Feel yourself within it, a single conscious point inside an infinite rotation. The universe is not something you look at, it is something you are. And maybe that's the final answer. You are not in the universe. You are the universe, remembering how it moves and learning through your own breath how to keep turning. You are not a witness to the universe's motion. You are the motion, the moment when the cosmos remembers itself.